Good morning panel, my name is Jatin Singh. My roll number is 102006169. My group number is 65 and I am a 4th year Electronics and Communications Engineering student at Thapar University, Patiala.
Good morning panel, my name is Tarush Sharma. My roll number is 102006150. My group number is 65 and I am a Electronics and Communication Engineering student in 4th year at Thapar University.
Good morning everyone. My name is Akshit Aggarwal. My roll number is 102006144. My group number is 65 and I am a 4th year ECE student.
Good morning panel. My name is Oishiki Ghosh. My roll number is 102006100. My group number is 65 and I'm an Electronics and Communications Engineering student studying in 4th year at Thapar University. Using sign language creates great gaps between people using universal language and sign language. We propose a software that will provide an efficient and accurate way to convert sign language into text or voice, enabling deaf individuals to communicate effectively in various settings. Translating sign language into natural language using deep learning relies on sophisticated algorithms. These algorithms are trained on large datasets of sign language photos, which allows them to learn how to recognize and interpret the gestures. Previously, this function has been facilitated through various other mainstream models like CNN classifiers, SVM classifiers, etc., with the highest accuracy of 98.66%. Our model provides an accuracy of a whopping 99% and projects our hard work and research embedded in the same.
The training dataset used in this project comprises of 29 total classes, including that of 26 English alphabets, delete, nothing, and space. Each of these classes have 3000 photos for the same. The testing dataset for this project comprises of 28 images working towards testing our algorithm. The first step is to start with importing all of the necessary libraries and packages required as shown. We then follow up with specifying the length of the train set, the number of classes, and making labels for respective alphabets in the dataset to facilitate further classification of the same. Next step was to load all of the 87,000 images from the training dataset onto the kernel to import each of the individual images. This will make each of them accessible for further processing. Here, we access an image randomly in order to make sure all the images have been imported appropriately and display it. Now, we install a machine learning library called scikit-learn, which features various classification, regression, and clustering algorithms, including support vector machines, random forests, gradient boosting, k-means, and dbscan, and is designed to interoperate with the Python numerical and scientific libraries like NumPy and SciPy. Here, using Keras, we define a neural network, adding 3 convolutional 2D layers, 3 activation, and 3 max pooling layers along with a flatten and 2 dense layers. It is important to acquire a summary of our model, which would tell us about the number of parameters we are working with. It helps us with an overview of the output shapes and their sizes. Finally, we compile the model. The specifications of the necessary parameters are: we used the ADAM optimizer, short for Adaptive Moment Estimation Optimizer, an optimization algorithm designed to update the weights of a neural network during training. We use the categorical cross-entropy loss function, also known as softmax loss. It's a softmax activation plus a cross-entropy loss used for multi-class classification. Using this loss, we trained a CNN to output a probability over the n classes for each image. Lastly, we use the accuracy matrix, which describes how the model performs across all classes and is calculated as the ratio between the number of correct predictions to the total number of predictions. This is a depiction of our models running and training. Finally, we display the model matrix to see how our model performed in comparison to other algorithms that were mentioned in the introduction. Plotting between loss and validation function loss in order to accumulate and understand our model's working. It is also necessary to plot between accuracy and validation function accuracy, and evaluating our model on X test and Y categorically. Lastly, we predicted labels for X test. We hope we communicated our aim with this project and showcased its truest potential in the best way possible. Thank you.